how comfortable are you all with like the lay of the land when it comes to networking and the internet? How many people feel comfortable? How many people feel, like, give me a little bit, give me your take on it. So one thing I wanted to look up before I came to class, I don't know what it'll show me, but I wanted to see if there was a good diagram that showed like internet network layers, right? Like, is there a good image that shows that? And I haven't looked this up before, but so that's kind of interesting. Application, presentation, session, transport, network addressing, data link, physical layer. That's kind of an interesting one. Upper layers, transport service. So here we have the physical network, the hardware, network interface layer, network layer like internet protocol, and then UDP, TCP, and then application layer. This would be like HTTP. And so the idea here is that, and again, you can check out Caleb's take on this because I thought he did a really good job of presenting it. But the idea here is when we're doing web programming, we're working with this upper layer. So we're not going to be working with the lower layer so much. But the HTTP stuff, we'll be working with that. And occasionally, if you wanted to, you could dip into TCP. Right? So when you hear about like WebSockets, that's working at the TCP layer, which is kind of like the layer where you make connections and break connections. And so that's why with TCP, you create a WebSocket connection and it just stays open, right? Checking to Daniel, make sure I had that right. And so, just basics of networking, you have your rules of communication, your protocols, and you have layers to a network stack. And you have your, OSI model, which Open Systems Interconnection model, which is going to show you something very similar to what we were just looking up, right? So we have the physical layer, and then around in here we have like the TCP layer and the HTTP layer up on top of that. And so the main point being that we work with the higher layer HTTP, but in the next series of slides, we're going to see how do you do this just at the TCP level. So I'll show you how to do it at the TCP level. And the network, the internet works with packet switching. So in the old days, the way the internet came to be, right, was in the 60s. DARPA said we need to have a way to communicate and continue to communicate if there's a nuclear war and some of our cities get blown up. So in the past, there was just switch networks, and you could watch like old movies, and you'd see the operators take the plugs and actually create a switch, right, between two locations. And so if that cable got cut, your communication got cut. And so they came up with packet switching, which you would have routers, and you'd break your message up into packets, and you'd throw it onto the network, and then the routers would look at the address like an envelope and figure out where is this packet of data supposed to be, and the routers would find a path. And so if one of the paths got cut or blown up or broken, those packets could still get to their destination via other paths. And so that's the packet switch network, and every packet has a destination. And so HTTP, TCP, IP, they're kind of like nested dolls, right? Like all those things kind of fit together and work together to make this entire system work. And so hypertext transfer protocol, transmission control protocol, internet protocol. So HTTP request anatomy, domains are mapped to an IP address, and then this is translated via DNS routers. And so, if I go to a domain, like, I don't know, yeah, Google, well, that's kind of like, I showed this one in the spring. If I go here, then that's like this web page, but then I could also start my terminal, and I could say, pingmclouds.com, and it'll show me the IP address, 72.29.31.4. So that's the IP address. And that's the location of this information on the internet. And we have domains because it's easier for humans to remember mclouds.com than it is 72.29.31.4. Right? And then those domains just map or resolve to that IP address. So when you type in mclouds.com, that request goes to a domain name server, and then the server looks up what's the IP address, and then it goes to that IP address and gets the information and brings it back. So, this was kind of interesting. I like this. I closed my terminal. Hey, now my terminal's a different color. What happened? There we go. So you can do that, and it'll list out like different IP addresses. Let's do digmcclouds.com, see what comes up. It's kind of different. I'm not as big as Google.
Yeah, Google needs a lot more computers to handle all the connections
than lowlymcclouds.com. So then we have buying a domain name. So you can just buy, you guys know that. You could buy a domain name like at Google Domains or other places. You can find out who owns a domain name with who is. And you can take a look at HTTP headers. And so, you know, like if I'm at mcclouds.com, I could then go into developer tools and more tools, developer tools. And the shortcut there is, what is that? Option Command I. Option Command I. There we go. And so then I could come down in here and I could start looking at the different resources they have. And it's actually been like a couple of weeks since I've looked at this.
I think F12 also works for developer tools toggling too.
F12. And then so if I look at this page that, you know, this image that came down, right, I could see the header of that request, and it, you know, gives me different information. So we'll learn how to, or we'll see again how to change these headers and adjust them and what some of the different settings do. So that same thing there. You could use curl to do different stuff at the terminal. So you could, you know, curl a web page, and that'll bring back the HTML. So there's all the HTML. I could curl and then dash capital I, and it'll show me the header. If all works well, I've had this not work before. It does just that and stops. So I think it might be blocked here at present state. I'm not sure why. But m-v, what's -v do? Let's try that. Curl -v golang.org. Gives us a little bit more information. Verbose. So TCP is the layer below HTTP, and TCP is the layer provides a reliable connection, puts packets in order. It's kind of what its responsibility is. You could use software like Wireshark to really sort of like monitor all of your network activity. Take a look at it. You could use traceroute to show a route to a website, you know, as you're, you know, making a request, what servers, routers does it go through. And today what we're really writing are distributed systems. We're writing software today that needs to run on distributed systems. And, you know, they'll have a client-server architecture or peer-to-peer architecture. And so this is just like a little bit of a layout of what that might look like, where you have a client, and then that makes a request, and it hits a load balancer. So if you have several servers, that could distribute the load across multiple servers, and then the server will make requests to the database, or, you know, some sort of data, and then build the page and then pass it back to the client. That's the basic layout.